offshoot of a college course, what young men who are studying perhaps engineering study this kind of stuff. And so I'm going to spend a little time with that, and I think it'll be kind of fun. And if nothing else, you can just look at a crane in a slightly different way and say, oh, that's the boom of the crane, or oh, that's the tension cable, or something, 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 that's the ballast, and maybe you'll get a little bit more out of it. So that'll kind of like be the major thrust. But what I want to do now for your viewing and listening pleasure is I want to just one more time, kind of go through a little bit of my Earth geometry, which I've done. That's the whole premise of this show, is kind of understanding the whole planet business. And it took me any number of years to figure it out, so I shared with you it. Now remember, ladies and gentlemen, here one more time, can we get a close-up, Andy? Remember that I always use for this thing the Farmer's Almanac as a kind of like the ongoing textbook. And the new ones are out. In fact, I haven't got mine yet, and I have to get it. So if you haven't got it in the past, you better buy it. 2005. They're going like hotcakes. But let me kind of pick this up here because I want to kind of explain that. I ran out of time, so I'll just back up a little bit and spend like no more than 10 minutes. So what I was explaining as the program was ending last time, I was talking about the concept of the equinox. Equinox is how the whole thing was starting up. So the equinox is like this, okay? And again, I'm just going to kind of go a little bit fast here. But looking at the earthy proof from the top, if you're just looking right at the top of the world, is at the equinox time, they were just say approximately 9/22 of every year, the planet is on that side of its cycle, and of course the sun is out here. Therefore, this would be what they call the line of illumination, and all that really means is that if the sun is the big giant light bulb, so to speak, well, obviously this side is lit and this side is dark, okay? And the reason why you get this concept of the equinox is because it's at that particular time in the orbital cycle that and this happens exactly in spring, it happens in fall, is that the planet is perpendicular, see? Perpendicular to the sun, right? You know what perpendicular means, right? It's like 90 degrees. So the planet is perpendicular to the sun, and so hence it is that for that reason why you have the 12 hours of darkness and the 12 hours of light. And this happens in the spring, it happens at the fall, and that's relatively easy to understand, but when it gets in between, that's when it gets kind of kinky. So, but one more time, this is kind of like where I ended, and I'm going to pick it up from here. So again, I'm going to take this point down and bring it down, a little descriptive geometry here, so bear with me. So this is our 45th parallel, okay, and as we're rotating in our 24 hours a day, and again, because I said that it is exactly even 12 hours of dark, 12 hours of light, hence, when we look out at our east and west horizon, like pretend that you're, I don't know, let's see, if you take away all the distractions, pretend that you're like on the ocean and you're sailing on a ship, okay? And there's no distractions, there's no cities, there's no trees, there's no houses, and you look out either when the sun directly rises in the morning or when the sun sets directly, in the evening, and if you had a compass on the time of the equinox, that would be in the spring and in the fall, is that the sun would appear to be exactly on the east-west horizon, okay? And again, because it happens to be that the planet is perpendicular to the sun at that time. Now, here's where we got to kind of jump off and stick with me, because here's where it gets a little sticky, and it's not obvious. And Wadswell has looked in any number of textbooks over the years to try to find people to explain this, and I really haven't found good things. So what I did is, on my own computer, over the years, I have generated any number of my little plates I've generated to explain the descriptive geometry. Okay, here we can get a close-up, Andy. Here you can see again, this is the Wadswell descriptive geometry plates, okay? And it's really quite simple. I just represent, the pink represents the sun, and then it just shows like the planet from the top and then the planet from the side. And then you kind of like make a third view, what they call an auxiliary view, and then you can trace, the amount of sunlight and so on and so forth. And it gets a little complicated. But I've just explained to you how the planet this equinox business occurs. But now we are getting into the phase where the days are becoming shorter. Okay, So what we're going to do, we're going to go one more time. So now, let's see, I don't want to spend all time on this, but we would just pretend that now, kind of like in the Where Are We segment, okay, so we're saying that our equinox was back to 922, so now we're back on the big Earth racetrack. So now we are past this point, so now the planet, we're already 10:08, so now we are already a little ways past this point. Therefore, the planet is no longer exactly perpendicular to the sun. Because remember, as the Earth goes like this, the axis of the Earth always stays kind of like in a straight line with itself. But then the sun appears to move. When we get into a different place in the cycle, like now we are past the equinox, so then the sun appears to be out here. Hence, with respect to that axis, we are no longer perpendicular to the sun. And because of the angularity of the planet, then the shadows start to fall different. Now again, this gets kind of involved, but I just wanted to explain to you that Wadsworth clearly understands this. It's taken me a while to do this, and I clearly understand it, and my ongoing fight is to make it so you understand it as well. And it's not always that easy to get it all out. So here we go. This is it. And I'm just going to do one more instance of in effect, what is happening between now and Christmas, and then the other parts of the Earth somewhat of the same pattern. I'm going to do this real quick now. So again, here we are. We're going to move in one more time. We're looking at the planet from the top, and the general direction of the planet always, because it's a big long orbit, tends to be a straight line. However, it's like I said before, is that because we're past the equinox, the sun appears to be out here somewhere. Hence, we go from the sun to the planet, and therefore, again, I use that perpendicular business. Therefore, it goes to the fact that the planet is somewhat perpendicular to the sun. So then this particular point right here becomes the line of illumination, okay? It's like I said before, what's on this side is light, what this side is dark. And it's interesting to note that if this were drawn into a real good scale, you would start to notice that, because remember we said before that you were talking about cutting everything exactly in half, and by the half would mean that half of the time it's light and half the time it's dark. Now it turns out that once you get past the equinox, if you would do this in somewhat of a scale and you would divide this up, you would find out that there is less than 12 hours of light and more than 12 hours of darkness. And to reinforce that intuition, oh boy, my time is flying here. To reinforce the intuition, we look in the old trusty dusty Farmer's Almanac, and on the 8th of October, lo and behold, it tells us that there are now 11 hours and 24 minutes of light. So hence we have already lost a half an hour of light. So we take this business over here real quick. I'm just going to start picking up here. So the planet always is rotating counterclockwise. So this becomes the sunrise. This becomes the sunset as we're rotating. There's now a little bit more darkness than there is of light. And to explain, looking at it from the top and then taking from this and making one review, I'm going to try to explain why you're starting to see the sun sets and the sun rises below the horizon, below the east-west horizon. In other words, if you're looking in the north and the sun comes up in the morning, it tends to be in the south, going to the south. And how that occurs is, again, one more time, I'm going to try to do this, showing you my descriptive geometry, is the planet comes over here. So now you're looking at it like from the side view, and this same point comes over here, and you got the same 23.5 degrees over here. But because the sun rays always come perpendicular, is that the sun always is going to be shining perpendicular. Therefore, as you get over here, your sunrise and your sunrise is going to start being a little bit less than this would be exactly 12 hours. It would be 12 hours light, 12 hours of dark. But when your sun rises and sunset get on the other side, and the sun rises and sunsets are always perpendicular, hence, if you look out on the horizon, it appears that the sun is rising or setting in the south. And the